Welcome to a new test and teardown video. This time it's a Heathkit Capaci-tester model CT-1. I was able to find a manual online and we can read the specifications. It is actually a lot more complicated than first anticipated, because when I look at the layout here, we have a switch AC off. Okay, we can go check two different types of check, the short and the open check, and then we have the then we have the actual test where we of course connect the signal to the test capacitor. And the idea is we can test open, and we can test for short, or we can test for random disconnectivity or whatever is the problem with the capacitor. This is of course a warm-up mode because there is a filament inside this magic eye. It says in the manual it is testing at either mains frequency or at a 19 megahertz oscillator. Really? So there's an oscillator, and the idea is the capacitor, if it's working, it's stopping the oscillator and this way changing the read out. Isn't that a little bit fascinating? I will put in a sheet of from the manual. It explains the way that this one works in text, and it is written in a way it's really funny. Please pause the video here and read this text and get into the right mood. I really like it. Let's look a little bit on the inside. I really love to do visual inspections before I plug in stuff like this. It is of course a very simple circuit. As we have already seen in the circuit explained, there is no rectifiers or anything. Everything runs on AC. So here's the transformer making about 500 volts of AC for the anode systems and 12 volt AC for the filament. And here is the little oscillator coil with two windings. And this is of course the one that's connected to the test in one of the settings. I did find a few things to talk about here. The first is this capacitor, and it is mounted between one of the mains input wires and chassis. So this screw down here is the chassis screw, and it goes here. Now it goes to this point here. So that is the capacitor, and it's ground here and stuff, but then it goes to mains, and you don't know how this is flipped. It could be phase or it could be zero. So you could actually have phase to your chassis via this capacitor. Why would you like to have that? So I better remove this or add a cable with proper earth connection to chassis. I really don't want stuff to be live on chassis. And then another thing, look at the two black wires that goes to this switch. That is the mains on-off switch, and since there's only one switch, so this switch is of course AC off, and then it's the warm-up, and then it's the test or warm-up and the other test. So that means we got three sections on this switch, two on the rear side and one on the front side. I think it's impossible to video this. Maybe I can get a little bit of light in there so you can see there is a little metal part here on this front side, and that is the mains. but the distance between the two, I don't know, layers, what you call the sections of this switch. Some of the metal goes through some tiny little holes in here and is bent a little bit to the sides. Let's see if I can get this thing to focus on that. I mean, it's about 1 millimeter or maybe even less. So it's not a super safe switch in today's distance safety measurements and regulations at least. So that is something I need to worry about. I don't see any leaked capacitors or anything black, brown or burnt. So I will of course continue. And here is this beautiful magic eye. 1629 is the type number, made by RCA. And I believe that is the year code. So it's from 1961. How nice. Yeah, the manual is from 1959. So they maybe made this over quite a lot of years, of course. Very, very simple construction. Probably also quite cheap. Well, let's try and remove this capacitor first. That is definitely what we need to do. So I dimmed the light and let's see if there is any kabooms. Let's first turn on mains and nothing bad happened. So we will go in the warm up here. And it is using 5 watts. So far, so good. See, I got a cable here. Oh, it is, of course. Oh, that is annoying. It is, of course, blinking on the camera, but not on my eyes because I don't see that in the same way. That is funny. I think it is a shutter time thing, but it is because it's running on AC. Okay, so this check should be open. That is not the case. Let's go to the other side and see if this one is... So they made it the other way around. So what they... that is crazy. Why do they do that? Okay, so that is the picture we see, right? Let's try and see if we can make it. So let's try and test a little bit here. So what I want to test is the open first. So here's just 1 microfarad. And so let's try and put it into the test. So now you can see it is open. It's really, really difficult to show this on the video for some reason. So if I connect it, see? So this seems to be working. So that means this 1 microfarad creates the current here that is necessary to reveal we have a good capacitor. How about that? And of course in the short test, this capacitance here is not enough to show any current here because this current in this capacitor is not enough. But if I take a short and then I have a clear indication there is a short. Wow, so this thing actually works. How about that? Here is the schematic of this fantastic capacitor tester. And like I already explained a few times, we got no rectifiers, we're running on DC, and you can see the 540 volts AC going directly to the magic eye. And since this magic eye both got a gate and a cathode, and I mean this sort of work like a normal tube would do with gain and amplification and all those things, that means of course it can work as an oscillator, and then DC current and oscillator current will change the behavior of the magic eye, and this way open or close the visual beam in it. And that is exactly what this inductor transformer and the capacitors they're doing. That's a little oscillator, and that is of course killed with or loaded to a full stop with the capacitor in place. And the reason for testing at a very high frequency, that is of course to test if the capacitor is disconnected, even if the value is very small. If you test it with only mains frequency, it would not be able to do that without another amplifier or some other diodes or some other much more complicated circuit. So this is just absolutely the cheapest, simplest way to do it. And I think that is such a good, genius design. That is all I wanted to show you in this video. So thank you very much for watching. Hope to see you soon again. Bye.